First of all, I want to thank Professor Hal Varian for accepting our invitation to give the annual opening lecture. This, as I said, is the 22nd edition of this Lliçó d'Economia, an event that has become a tradition in a relatively short life of our university, and clearly a success, as we can see from the audience. So I'll first give the floor to the Dean, Vicente Ortún, which I believe he's been with us for many years, but I believe it's his first opening lecture as a Dean.
Yes, I was in the first, this is the 22nd, and despite that it's much easier to say 22nd than 20 let me, Professor Varian, allow me some words in Catalan for our constituency. Sí, ara sóc el degà, des que va marxar l'Albert Carreras. Fa 21 anys que va estar Kenneth Arrow, Premi Nobel. Des de llavors han passat 6 Premis Nobel més i d'altres economistes molt distingits, com el que tenim avui d'invitat. Fa 10 anys, i cal reconèixer, el suport que el Laboratoris Doctor Esteve, a la seva dreta, i Garrigues, a la seva esquerra, que han patrocinat aquesta conferència durant 10 anys. Aquest acte s'adreça tant a estudiants com a professors. Dins dels estudiants, particularment els de primer curs, aquest any tenim 709 estudiants en aquesta facultat, als 4 graus que ja assistien l'any passat, més a un nou doble grau en Dret, Economia i AD. Una paraula molt culta. En temps molt difícils, com els actuals, la facultat vol enviar el missatge que, malgrat una retallada del 15%, volem que la qualitat no es quedi ressentida. A les classes de matemàtiques, per exemple, no explicarem una de cada 4 equacions amb una solució equivocada. Es notaran algunes incomoditats, però la majoria d'aquesta facultat, malgrat que està una mica dolguda amb les retallades excessives dels associats, que afecten particularment aquesta facultat no té la postura que tenen alguns elements de la societat de dir quan resolgui el món, que em toquin a mi. Nosaltres hem de tocar i hem de canviar abans que resolgui el món, perquè som una part de la solució. I res més. La nostra intenció, i això sembla que sempre es diu, és aquest any ha hagut un augment, torna a haver un augment importantíssim de la qualificació dels estudiants que entren i el nostre desig està a l'alçada de les capacitats i les expectatives dels que heu entrat. I ara el professor Tom Bosch, editor, entre altres coses, dels llibres del professor Varian, farà la seva introducció.
Bon dia. Hello, everybody. It's a pleasure. It's also an honor, I have to say, to present Professor Varian to this audience. A few weeks ago, I was talking to a student, and I told him, you know, Hal Varian is going to be presenting the inaugural lecture at the Facultat, and he said, Varian, a guy named after a book. Yes. Yes, a guy named after a book. But he has also other achievements. Let's look at another book. This book is going to be published in a few months. It's called Are You Smart Enough to Work at Google? And if we apply the question to Professor Varian, the answer is indeed. He's smart enough. Hal Varian is a chief economist at Google. He's also an academic. He has been professor in many places. Lately, at Berkeley, he was professor at the Department of Economics, at the Business School, at the Information Management School. He was the dean of the Information Management School. I think you resigned from all those positions, and now you are chief economist. You see, nowadays, presenting a speaker, it's totally obsolete. You go into Google, you type Hal Varian, and you get everything you want to know. So I don't want to continue telling you the many things that Professor Varian has done in his life. I just want to make one remark, because I think that could be very interesting for you students. For many years, he was publishing a monthly notice, a monthly column in the New York Times. those were extremely clever, extremely smart. That was long ago, and yet you should read them because you learn a lot from them. So please, read his textbook, but mostly read his columns. They were excellent. Now, I'm told that today you are going to be defying common sense by saying that you can make predictions. We know that it's tough making predictions, especially about the future. You are also going to define economic theory? No, you're not aware of that. Lucas keeps reminding us that one prediction, probably the deepest prediction of economic theory, is that we cannot make predictions about many economic events. Let's say that there is a prediction that La Caixa is a local savings bank, is going to go bankrupt in 1 month, and that this prediction is credible. What will happen? People will act on this prediction, and La Caixa is going to be bankrupt tomorrow. So it's very difficult in economics to make predictions unless your prediction, nobody believes it. The predictions that can be accurate are the ones that nobody believes. Anyway, it's time for you to talk about your predictive powers. So the floor is yours. And this is for you.
Thank you very much for that kind introduction. And since I've discovered I'm named after a book, we should now open the book and start the lecture. And in fact, as you heard, predicting the future, it's very difficult. So I'm going to lower the bar and just try to predict the present, which is also known in economics as nowcasting. Instead of forecasting, we're going to do nowcasting. And this, I should say, is joint work with my team at Google, Hun-Young Choi, Steve Scott, and other members of the team. So I have a question. I have a question for the group. Let's see. Which day of the week are there the most searches for hangover? Resaca, I guess, in Espanol. So how many people say Sunday? How many people say Sunday? And how many people say Monday? How many people say? And Tuesday. Tuesday. No Tuesdays? Wednesday, Thursday, Friday? So these are the people from the Erasmus group that you were telling me? Okay, well, the answer we can easily find using Google. We have a nice tool here called Google Search Insights, Insights for Search. And I go there and I type in hangover. I say the United States. I pick a range of dates. And we see this very, very regular pattern where it peaks, as it turns out, every Sunday. So you were right, very experienced group. And this anomaly here, this is January 1. So it's quite a regular pattern with minor exceptions. And let's see here. And we can look at the geo, the hangover capital in the U.S. is New York, not surprisingly. And here we can see the top searches, hangover cure, a cure for hangover. And here we see the rising searches. So this is a little picture of how this works. Now you can actually do the same thing in Spain. Let's see if I can, there we go. Oh, sorry, before I do that, here I can search for two things. I search for hangover and vodka. And the searches on vodka peak every Saturday. And the searches on hangover peak every Sunday. And this, of course, is New Year's Eve. I tried the same search for resaca here in Spain and around New Year's Eve, and we see pretty much the same pattern. January 1st is the peak. I look at the San Juan's Day, and we also see the same effect. By the way, Valencia is ahead of Barcelona, so you have some work to do. Maybe you can admit some more Erasmus students next year. This is a nice example. This is for the U.S. again, for Civil War, very popular historical subject. You see this extremely regular pattern repeats year after year. What is the pattern due to? Well, as every professor will know, this peak is 3 days before the term paper is due. And in fact, we can verify that by looking at the pattern of searches on Civil War and searches on term papers, and you can see they have exactly the same cyclical behavior. It's much like vodka and hangover, term paper and topic. Another example, this is a search for marginal cost in the US and Australia, and you can see this interesting pattern due to the different term calendar in Australia. And finally, this is, I think, quite interesting. We're moving into my topic, which is about economics. These are searches for descuento y rebajas in Spain. And you can see how it was a relatively not much change up until the time of the crisis, and then we've seen a big increase in searches for discount. And down here are the searches for the sales. And we see a big surge in the last few years. So people have become much more price sensitive because, of course, of the economic difficulties in Europe and the US. And this same pattern occurs in the United States as well. So those are little examples. You can see that Google data is kind of a database of intentions. It gives you some insight into consumer behavior. And my thought was we should try to use that data to help predict, or at least nowcast, the economic variables using that data from Google Search Insights. So the idea then is to take the, there we go, economic index you're trying to predict. You use the standard econometric techniques to try to predict that series from its own past values and maybe other exogenous variables, but you add in the search data to try to improve predictions of the economic index. Now, this doesn't work for every possible index, but we've had some pretty good experience with interesting economic nowcasting using this technique, and that's what I want to talk about today for the next 20 or 30 minutes. So the recommended procedure for using this data is to fit the best model you can using the existing data, which is usually the time series, the univariate time series. Typically that will involve estimating seasonal effects and trend components. Add the Google data as an additional predictor, and then look at how the out-of-sample forecast improves using mean absolute error in our case. And we're particularly interested in turning points, since turning points are the hardest thing to forecast. When the economy is going like this, it's easy to forecast. When it's going like this, it's easy to forecast. It's the turns that are difficult to forecast. So that's our primary concern. Now, there are some issues in using the data. One is the data is mixed frequency. The Google data is available on a daily or a weekly basis, and most government data is only available monthly or even quarterly. But that's very helpful because it gives you advance notice, a sort of leading indicator or early warning of changes in the official data. The Google data is an index. It's a normalized query share. So when I showed you the searches on hangover or resaca, those were searches on hangover divided by the total number of searches. So it's looking at the relative share of a given query to total volume. You have to have at least 50 or so observations to appear in the data. That's because of privacy reasons. We don't want queries that are very, very personalized. It's sampled data, so it will vary a little bit, a few percent from day to day. And finally, you can look at the data in context, because many, many terms are ambiguous. If you search for apple, you could be searching for a fruit, you could be searching for a company, you could be searching for entertainment, music. So we want to, the technical term is disambiguate, eliminate the ambiguity by looking at searches within context. So, for example, this is what Apple, searches for Apple look like in food and drink category. Very, very regular. They peak every November. And this is what Apple looks like in the consumer electronics category, where it tends to peak around Christmas time and whenever the company makes an announcement. There will be a surge of queries on Apple. It's the same term, where we're looking here relative to food and drink, and here looking at consumer electronics. And this could be very important for economic data. If you're looking for information on jobs, well, do you mean work or do you mean Steve Jobs? So having the capability of ambiguating, disambiguating is important. Whoop. And you could also look at searches by category alone. So this is a search, there's no term, there's just vehicle shopping as a category, and we have this data on queries that seem to be related to vehicle shopping, with a big surge in the summer of 2009 when we had a program in the U.S. to subsidize the purchase of new automobiles. I think you might have had something like that in several countries in Europe. All right, so let's talk about something serious. Now, we've used some fun examples. We'll look at some economic examples. Unemployment. It's a very important topic, of course. Having a little trouble working the clicker here. There we go. So in the United States, we have something called initial claims for unemployment benefit. What this means is if you're laid off from your job, you go to the office, you say, I've become unemployed. They set up the procedure to pay you your unemployment benefits, and they file that in the computer. And each week, the Department of Labor reports how many people filed initial claims for unemployment in the previous week. So the data is released with a 1-week lag. Now, this number is very useful because it is the best single indicator of the end of a recession. So the pink bars here are recessions, and the black line is the initial claims for unemployment, and you notice how it peaks right at the end of the recession. So it's the best single indicator for end of a recession. The red line is the unemployment rate. That tends to peak about 12 to 18 months after the peak in initial claims. So the initial claims is a very good predictor of unemployment rate about 12 to 18 months in advance. This is the data. Go back here. Let's see. This is what it looks like if you look for welfare and unemployment related queries on Google. These will be queries where people are typing in, how do I file for unemployment benefits? Where is the unemployment office? How long does unemployment benefits last? And so on. And this shows a very similar pattern of being very level for many years and then increasing during the recession. These are the kinds of queries that people ask: unemployment benefits, Social Security, food stamps, Department of Labor, unemployment office. All these are unemployment-related queries. And here are job-related queries: job search, resume, job search engines, LinkedIn. And over here is the demand side of the labor market, the recruiting and staffing, mostly for hiring temporary workers. So these are the categories in that Google data that are related to the labor market. If you overlay the initial claims, the government data, with the welfare and unemployment data, you can see there is in fact quite a strong correlation between the two series, and so it's natural to build a little econometric model. So we build a baseline model where we say the log of initial claims this week is going to be phi times the log of initial claims last week. That turns out to describe the data pretty well. And then we add in to that regression the jobs data and the welfare data that I just showed you, taken from Google Trends. And it turns out you get quite a good improvement in the prediction. If you look at something where you're predicting 1 week ahead, that is, you're predicting this week's initial claims based on this week's queries, recognizing that the data will not be released until next week, so you're doing contemporaneous prediction, predicting the present, but in advance of the actual data release, we find about a 16% improvement in the forecast accuracy. And that's particularly important around the April 2009 turning point, because that's the time when the initial claims peaked, and since then they've tended to decline. So it's quite helpful in predicting that particular turning point. And if we look, if we look at the other turning points in the series, we see a similar behavior where we saw the peak of the series, and then later on in 2010 we saw a flattening out for a period. Then in sort of late 2010 we saw a resumption in the decline. That's good. But then recently it's come back up, and this is why people are concerned, of course, that they're seeing a possibility at least of another recession emerging, and one of the pieces of evidence for that is looking at this unemployment-related data. Now, you can also look at the seasonally unadjusted data. So I was previously looking at seasonal adjustment. If you look at the seasonally unadjusted data, this is for the specific query, file for unemployment, and we look at the difference between the baseline, which is just the univariate regression, just straight time series forecasting, the actual, which is in gold, and then using the trends data, which is in red. As you can see, we get a substantially improved fit by adding that regressor to the model. So it does seem to be helpful in looking at unemployment, and we've seen the same kind of effect arise for Israeli data and for German data. Another example is to look at travel destination planning. So people plan their vacation. One thing that's quite prominent is when people are feeling relatively good about their economic situation. They plan luxury vacations, big vacations. When people are feeling more pressed, they plan more modest vacations. So it's quite interesting to examine this from an economic viewpoint. We looked at data for Hong Kong, and the reason we did that is the Hong Kong Tourism Board posts all their data on the website, so it's quite easy to get the data for visitors to Hong Kong. This is what it looks like if you look at U.S. data, Canadian, Great Britain, Germany. Is Spain on here? No, Spain is not on this list. But you can see the arrivals, and then here we can see what the queries look like, what the activity, search activity on Google looks like. You build a little model. This is the model we used. I don't want to go into details, but we basically looked at the queries in the first 2 weeks of the month and used the queries to forecast the visitors. So we took visitors from last month, queries from the first 2 weeks of the month, and then we used that to forecast the visitors for the current month. And we get really remarkably good fit if you look across this data. So that says you can forecast essentially a month in advance the arrivals to Hong Kong. In fact, if you look closely at this, it works quite well for most countries. The one country that was off a little bit was Japan. But you see the visitor arrival for tourism, for planning, all these things. You can get, I think, some useful insights from the Google data. All right, so to summarize so far, we have data with hundreds of categories of predictors, millions of queries. It's easy to acquire and work with the data. Everything I showed you uses public data. You can download the Google search data yourself. There's nothing exclusive about this. But it raises a number of research challenges. And the challenges would be, how should we select predictors? So far, I've just used common sense. I've used natural economic predictors, but are there better ways to do it? How should we make forecasts? How should we evaluate performance? And then how should we handle this mixed frequency? The fact that we have very high frequency data available from the search engine, we have low frequency data typically available from the agencies. So Herb Simon, who won the Nobel Prize 15 years ago, once said, "A wealth of information creates a poverty of attention." And so now the challenge is, how do we allocate that attention efficiently among an overabundance of information sources? So previously in econometrics, we had a few data series: inflation, unemployment, GDP, things of this sort. But now we have potentially millions of predictors. So how do we decide which of the many, many series that we have are useful in terms of predicting or nowcasting economic data? So the nowcasting term is due to David Hendry and his colleagues at Oxford. They point out there are three aspects to it: predicting the present, what I've been talking about so far; updating forecasts as new information becomes available, that's the mixed frequency estimation; and then variable selection. Out of many possible predictors, which one do you choose? And of course, there are many different ways to do variable selection. It's something of an art more than a science, but I believe it will become much more important in the future, because the abundance of information is creating challenges in terms of how to use that information effectively and how to choose the best predictors or the best correlates out of the set of available correlates. And it's not just in econometrics where this is important. This kind of statistical methods are very important in genetic markings, trying to associate genes with diseases, machine learning, data mining, many other areas. So, how do you choose a model when you have many possible predictors? There are all these predictors in this haystack, and we need to find the needle. We need to find the best predictors, so the ones that work best on a going forward basis. Now, the challenge is, as a mathematical point, you can always fit n observations with n predictors, or at least almost always. And even if you have fewer predictors than observations, you still may find a good fit just by chance alone. Two events might happen to have occurred at the same time. So the correlation can be due only to seasonal correlation, not a causal or even not a causal connection. So what you want to do is you want to measure the incremental improvement of your regression over a simple trend seasonal extrapolation. So it's very easy to engage in the sin of overfitting, of trying to fit the data too tightly. Well, there we go. So this is just a little picture. Normally we think of regression as being something where we have a few predictors and a lot of observations. Well, now we have a lot of predictors and relatively fewer observations. So if we just have the same number of regressors as observations, we fit perfectly, and we might find some subset of the data that just fits well by chance. So these are the dangers we have to watch out for. Here's a recipe of how to get a high R-squared. Maybe the professors should cover their ears while I explain this to the students, but take some white noise. So these are two series that are completely uncorrelated, but suppose they have a common trend, suppose they have a common seasonality, then of course you end up getting an appearance of strong correlation. It's not the series themselves that are correlated, it's just that they have a common trend and a common seasonality. So it's very difficult to avoid this trap, and you have to be quite careful in making sure that you remove the trend and remove the seasonality before you try to see if there's a relationship between two series. Oh yes, you run the regression and then you submit the paper. I forgot the last part. So here's an example. This clicker is a little sticky. Which is a better predictor? So here I have in the blue line, I have automobile sales, and I have two possible sets of queries from Google. One is the red one, Q1, and the other is the gold. If you look at that, I would say most people would think that the gold series looks to be more correlated with the auto sales than the red series. The red series just has that one spike, not much of a predictor. But in fact, if you seasonally adjust the data, if you take out the common seasonality, it turns out, see here, if you took out the seasonal adjustment, it turns out that the spike actually catches this big change here, whereas the gold series misses it entirely. The mean absolute error is about 7% smaller using the second query than the first. Why is that? Well, if we look, Q1 is clunkers. That was the program commonly known as Cash for Clunkers, and Q2 is bathing suits. So bathing suits look like they're a good predictor of automobile sales, but that's just because they both could max out in the summer. They have a common seasonal effect. As it turns out, clunkers was a much better predictor because the program that I described earlier, the subsidy for automobile purchase, was called Cash for Clunkers. All right, so you want to look at the incremental value of predictors. How much better can you do with a given predictor than by just using past value of the series? And of course, when you take your econometrics classes, I'm sure you've learned about whitening or pre-whitening the series, or Granger causality. These are techniques that try to deal with finding predictors that have incremental value over and above the seasonality and trends. For what we're doing, we can use just a very simple version of this. Run your favorite time series method on the predictors, run your favorite time series method on what you're trying to predict, and then see whether the residuals from the first regression help improve the forecast of the variable you're trying to predict. So you take out the part of the series which is predictable from its own historical behavior. One little tool that Google's released is a tool called Google Correlate, and with this data you can upload a time series and say, find me the queries that are most correlated with that time series. So in this particular case, I uploaded the initial claims for unemployment, the data I showed you earlier, and it said, here are the terms which are the most correlated with that. Idaho unemployment, Michigan unemployment, unemployment filing, unemployment, Michigan, etc. So in fact, the correlation, just mere correlation, was able to find these queries that were highly correlated with the actual time series. And this is a picture of what sign up for unemployment, that term, how well that was correlated with the actual initial claims for unemployment. So you can see it's a pretty impressive correlation. Unfortunately, this is not available yet for Spain, but our intention is to release it for other countries in the next several months. So how do you automate model selection? How is it that you can find predictors that make economic sense and are useful in the future? As I've mentioned so far, I just picked things that were natural. I used economic judgment, and in fact, economic judgment is a very good guide. But we want to see how well we can do with computers, so let's try that. This is an example of Australian consumer confidence. I was in Australia a couple months ago, so I prepared this using some data from Australia. Notice that consumer confidence in Australia went along. It fell during the initial phases of the recession, but then Australia was not really impacted very much by the recession because China spent so much money during this period, and Australia exported a lot to China. So in fact, the consumer confidence was down only for a few months and then rose back up to pre-recession levels. So it was quite different than what we've seen in the US and Spain and other countries in Europe. So I took 333 Google categories from the Google Search Insights, and I took the first 2 weeks of the month for searches in those categories and said, how well can you do in predicting the entire month just from using the first 2 weeks? And this particular time series is released weekly, so we were looking at predictions for about 3 weeks ahead of the actual data release. And, oh yes, I estimated it up to 2010 November, and then I forecast out of sample on the next 6 months. So, what do we use? Did I miss a slide here? No. What do we use? Well, we used a somewhat sophisticated technique. It's a method called Bayesian model averaging, or spike and slab regression, that's basically looking at a Bayesian technique to try to do the variable choice. Each variable has a prior probability of entering into the regression, and then we run the model and calculate the posterior probability, average a bunch of things together. I don't have time, obviously, to go into the details, but it turns out that the three variables that it chose were, in fact, crime and justice queries, trucks and SUVs, and hybrid cars. And with just those three variables as predictors, we get this quite good fit to the Australian consumer confidence. I should say, plus, of course, the value of consumer confidence last month. So we're using a one-period autoregressive model, and then we're adding these as additional predictors. Now, the trucks and SUVs and hybrid cars are not at all surprising, because when you look at U.S. data for consumer confidence, it actually is very sensitive to the price of gasoline. And hybrid cars and trucks and SUVs are very sensitive to the price of gasoline. When the price of gasoline is low, the Americans and Australians want to buy trucks and SUVs, and when the price of gasoline is high, they want to buy hybrid cars. So this effect here is really quite expected, both in U.S. data and Australian data. Crime and justice was a bit of a surprise, but it turns out it ends up being quite a helpful predictor in this model. So, let's see, the example there is illustrative. You can do the same sort of thing for any kind of consumer confidence. All of my examples so far have had to do with Google, but I want to point out that this is in fact a general phenomenon, because if you look at almost any large company, they have a data warehouse. You can go to MasterCard and they will give you or sell you the data about how many sales there have been in a given region in the US on a daily basis for a given retail category. So that data is available at a very, very high frequency. Same thing is true for UPS and Federal Express, for Walmart, for Target, and I'm sure the same thing is true in Spain. Nowadays, many private companies have access to vast amounts of real-time data that can be used for the same kind of nowcasting that I showed you using the search engine data. I think the government agencies have much longer historical series, but usually a much lower frequency, since the government data is generally released on a monthly or a quarterly basis. So the challenge, I think, that faces our profession and that faces the government statisticians and the private statisticians is how to combine this high-frequency, real-time data, vast amounts of it, with the lower frequency but much longer history data from the government sector. So I see this as a challenge that we will face over the next 5 or 10 years, but I hope that we can do this successfully, and the techniques that I've described here of trying to do the variable selection, the model building, the nowcasting using this data will become part of our professional training in the next decade. So I think that's a good place to stop, and I'm happy to take a few questions. Thank you.
Yes, thank you so much, Professor Varian. That was a very exciting conference. Let's see if we have questions on the floor. Is anyone having a micro? Okay, so
I do. So
whoever has the micro, go. Yeah.
Thank you. So Google has different market shares across different economies, and I was just wondering if you, in your research, you've noticed any difference in predictive power based on the market share of each country.
That's an excellent question. I've looked, for example, at different regions. So you can look at state-level data within Spain. You can look at just Catalonia or Andalusia. And it's true, when you have a smaller region, the series tend to be more noisy. But the flip side of this is it allows you to use panel data techniques. So you can look at both the time series and the cross-section, which is quite helpful. The Google data only goes back to 2004, so having the geographic variation is also quite helpful. So the answer to your question is absolutely. If you have smaller countries or smaller regions, the data gets more noisy, but then you do have the advantage of geographic variation. She's good.
Thank you very much for your presentation. I was wondering if you've done anything related to political predictions, and what would be the ethical considerations of making such predictions? Thanks.
So that's an excellent question. We've looked at some of the debates, presidential debates in the U.S. We looked at the UK debate, was that 2 years ago, the UK elections? What's interesting there is this bias towards new candidates. If it's some candidate that everybody knows about, then you don't see as many queries. If it's a new face, like in England, Clegg, the Liberal Party leader, he got by far the most queries because people wanted to find out about his history. And now in the U.S., where we have this large collection of Republican candidates, they're getting a lot of interest because they're not nearly as well known as the incumbents. So I think the question is, when you look at political data, what you're mostly seeing is the interest that people show, but we don't really know if that interest is positive or negative. We don't know how it affects voting behavior.
I have two questions. First, is there any way to build perception indexes based on this data? Because I'm thinking a lot about corruption, for example. And second, how have you thought about using this data to prove or disprove the predictions of a theoretical model?
So that's a very interesting question. The first question was on corruption, or what was it? Say what? Perceptions, yes. I have not done that myself, but I think that's quite an interesting research area. And with respect to looking at predictions of a theoretical model, there was a very interesting paper just published from a couple students at Stanford University who looked at job search intensity and the length of unemployment benefits. So what's happened in the U.S. is because of the severity of the recession, there were some increases in the duration of unemployment benefits. I think it's up to 99 weeks now. And each time those extensions were announced, you could look at the query activity on Google related to jobs. And so there are different theoretical models about what the impact is of changing unemployment benefits on intensity of search, and this data allowed them to resolve some of those questions, at least for online search. So I think it is useful not just for prediction that I've emphasized today, but also for model analysis, hypothesis testing of that sort. Is that dead? The reason I'm here today is I want to encourage all of you to look at this data. So it's very useful data, lots of interesting topics, so have at it.
I had a question over here.
Where? Way back there.
Yes.
All right.
Isn't there a risk of an interested party wanting to tamper with the data? So, for example, in the case of the Republican nominations, if somebody, wants to look like they're the consensus candidate, they can make a lot of searches with spyware and stuff like that.
Yes, so of course. So the question was, what about people who try to manipulate this data? We know there are, that does go on. We do have at Google what we call spam filters. So if you have a whole bunch of queries from the same IP address, or you have the same query popping up at the same time in different areas that looks suspicious, we tend to filter that out of the data. So we're certainly aware of that possibility. Right now, we haven't put a huge amount of work into cleaning this data. It's just gone through our normal procedures, but I think you're right that if this technique becomes very widely used in the future, we'll have to pay more attention to that problem. But there are ways to deal with it. It's not an insoluble problem. It's just annoyance. Okay.
I think we're done with questions, so thank you, Professor Varian, for this wonderful lecture. Before we close down, I would like to just give a few words on behalf of the rector. This is, again, another year that I've been asked to represent the rector in this very important opening lecture. And it is, in this year, it's really important to talk about the success of this whole project, because these are hard times, and we've been in a crisis for many years now. And the crisis is arriving to the public sector and to the universities. And UPF is not an exception. But the quality of the professors that we have been able to get a lot of competitive funds, and the quality of our students keep us at the very top of the universities. So with these two things together, we are able to keep going, not only as we've been before, but actually trying to improve in many respects. I would like to mention that our faculty not only contributes to research in the frontier and to quality of teaching, we try that very hard, but also actually this year we have been contributing to improve, at least we hope to improve the economic policy and managing at the government level. You know that, many of you may know that we have Andreu Mascolell leading the economy in Catalonia and also the university policy. Our previous dean that was sitting here last year, Albert Carreras, who is actually his right hand in managing the economy in our country, and also Frederico Dina, who some of you may have had as teaching mathematics or statistics. He's directing now the Institut Català d'Estadística. So maybe all of them, we will inform them of this nowcasting that Professor Varian has taught us, maybe that may help a little bit in redirecting our economy and getting a little bit of a higher success. Before we go, I would like to thank, as other years, our sponsors to the Lliçó d'Economia, Garrigues Abogados, represented by Mr. Miquel, and Laboratoris Esteve, represented by Mr. Raffles. They not only have been sponsoring the lecture, but also them and others, people from different firms, are helping us in designing our studies and to try to achieve the best professionals graduating from our university. We together aim at offering to the society the best graduates that can have sound economic formation, but also open thinking and the best opportunities in the job market. So I think I officially have to say, declaro inaugurat el curs 2011-2012 de la Facultat de Ciències Econòmiques i Empresarials. Thank you very much, Professor Varian.
Thank you.